Hi there. In this video, we're going to look at the method of completing the square. Completing the square is an incredibly important method because it always works. It'll work on any quadratic equation. And because of that, because it always works, that's the method that they use to prove the quadratic formula. If you ever wondered where the quadratic formula came from, it comes from completing the square. Okay, so let's go down and we'll take a look at this. Please excuse my video. It's from a time when I didn't have as good audio equipment, so it's a little bit not as nice, but hope you can bear with it.
So completing the square is a method of solving a problem by taking what's there, even if it's not a perfect square, and rewriting it so that it becomes a perfect square. Okay, so let me show you an example. So I'm going to do something to this to help us solve it. And it's going to seem very mysterious at first, but then I'll show you how I came up with it. Okay, so what I'm going to do is I'm going to add 9 to both sides of this equation. And you're probably thinking, 9? Where does 9 come from? Well, that's what I'll tell you afterwards, okay? But I want to show you what it does. So I'm going to add 9 to both sides. Well, here's what it does. The right-hand side, whatever, it becomes some number, 16 in this case. The left-hand side, though, has become a perfect square. The left-hand side has become x minus 3 squared. And you can check it. If you square this out, square out x minus 3, you'll get this stuff. And that's fantastic because now we can use the square root property. So what do? I'll use the square root property. It says that x minus 3 is equal to plus or minus the square root of 16. So in other words, x minus 3 is equal to plus or minus 4. So if I add 3 to both sides, I get x equals 3 plus or minus 4. This is giving me 2 different solutions. When I subtract 4, I get -1. 3 minus 4 is -1. If I add 4, I get 3 plus 4 is 7. X equals 7. These are my 2 solutions. Okay? Now that, like I said, that was probably mysterious. Like where does this plus 9 come from? Well, that's the whole point of completing the square, is finding out how to come up with this number, and then realizing that if you do it right, what you'll have down next is a perfect square. So let's talk about where this number comes from. So let me just, that's the whole point of completing the square, is finding that number to add to both sides. What you have to realize here is the formula for a minus b squared. If you remember that, that was a squared minus 2ab plus b squared. Okay, that's the perfect square formula for a difference. Okay, if I put an x in here, x minus b squared, then it becomes x squared minus 2xb, but let's do it the other way around. Let me write 2bx, same thing, plus b squared. Okay, so let's look back at my problem that we had here. I had x squared minus 6x. All right, so what I'm doing is I'm matching that, this thing right here, I'm matching that to this right here. All right, and I'm asking, what does b have to be in order to get the 6? Well, I've got 2 times b, so therefore b must be exactly half of 6, right? It must be 3. So if I put a 3 here, then this underlined thing will be exactly the same as this underlined thing. Okay? And then I add the 3 squared, then this thing will be that perfect square. And then that's how I got from here to here, and then I knew that that was going to be a perfect square like this. I took half of this number, and then I squared it, and that's the number that went right here, because that's what's happening here. 2 times b is this number, so that means b must be half of that number. And then the thing that's right here is b squared. And if I write that out, I can factor it as x minus b squared. So let's do another one. So let's match this up to what we see over here. I've got x squared minus 2 times b. So what do I multiply 2 by to get 8? Well, it's a 4. So what comes next is a 4 squared. So what I want to add to both sides is 4 squared, so that I end up with this thing on the left. So that's what we're going to do. We're going to add 16 to both sides. The 16 is b over 2 squared. So what happens? So I get x squared minus 8x plus 16 equals, when I add those, I get 26. Oh, why did I write 24? I get 26. All right. And this is guaranteed to be a perfect square, because this formula comes from this, right? This expression comes from this expression here. So how do I get back to this? Well, whatever my b was, that's what is being, the x minus that is what's being squared. So what was my b? Well, 2 times b was 8. My b was 4. So this is x minus 4 squared. This number is always half of that number there, because that was the b, and 2 times b is this. So now I'm going to use the square root property. The square root property says x minus 4 is equal to plus or minus the square root of 26. Root 26 doesn't simplify. It factors as 2 times 13. 2 and 13 are prime numbers. They don't have any other factorizations. So there's no perfect square factors. So I just leave it like this. I add 4 to both sides. I get x equals 4 plus or minus root 26. That's my final answer. Okay. Let's do another one. Okay, well, here we have a plus, all right? And those problems up here, we had a minus. So we better think about how we're going to deal with that. Well, the minus came from this formula, but we have a similar formula for when this is a plus, okay? What is that? Well, why did I write down there? I wasted a piece of paper. What is that? What happens there? I get a plus b squared is a squared plus 2ab plus b squared. So it's almost the same, except instead of a minus 2ab, I have a plus 2ab. But everything else is the same. It's a 2b. The 2b has to be this number. So again, b is going to be half of this. And then I'm going to add b squared. So I'm going to take half of 14, and I'm going to square it. That's what I'm going to add to both sides. So 14 over 2 squared is 7 squared. That's 49. That's what I'm adding to both sides. So I'm going to put plus 49. So I end up with x squared plus 14x plus 49 equals 15 plus 49 is 64. Okay. This is supposed to be a perfect square, because if I just run this backwards, this becomes this. A plus b squared. So it should be x plus, what was b? It was half of this, x plus 7 squared. So now I know that x plus 7 must be plus or minus the square root of 64. I know what the square root of 64 is. It's 8. X plus 7 equals plus or minus 8. subtract 7 from both sides, x equals -7 plus or minus 8. I can write that another way. If I take -7 minus 8, I get x equals -15. If I take -7 plus 8, I get x equals 1. So these are my two solutions to that problem. So we're just adding something to both sides of the equation that make the result equal to a perfect square. And that's why it's called completing the square. You're adding that one piece that was missing that was keeping this from being a perfect square. So let's do another one. There's two approaches here. I can just ignore the 9 and just look at this stuff and ask, okay, well, do I have to add to both sides, and just add it to both sides? Or it might be cleaner if I just subtract the 9 from both sides first, so that it looks like the previous problems. Okay, so let's do that. Let's subtract 9 from both sides first. Now it looks like the other problems that we had. Now I want to know, what do I add to both sides so that I get a perfect square on the left? You take half of this, it's 2, and you square it, it's 4. Very good. So I'm going to add 4 to both sides. What happens? I get x squared plus 4x plus 4. This is supposed to be a perfect square now. And sure enough, it's x plus 2 squared. So we took something that wasn't a perfect square, right, and we turned it into something that was. So this was just, when we got to here, it was just missing one little number that was keeping it from being a perfect square. And so we added that number. We completed what we needed to get it to be a perfect square, and that's why we call it completing the square. So now we use the square root property. All right, square root of 25 is 5. So x equals, if I subtract 2 from both sides, -2 plus or minus 5. Another way to write that would be -2 minus 5 is my first answer, -7. Then my other answer is -2 plus 5, which is 3. Okay. Let's do another one. Let's do something with, let's see what happens. In all these examples, I was easily able to cut this number in half. It was always a multiple of 2. What happens if it's not a multiple of 2? So let's try this. X squared plus 3x plus, I don't know, 1 equals 8. Okay. At this point, you could just write any number. I'm not even preparing these problems in advance. I'm just putting numbers in here, and we can always solve these. What do we do here? Well, same thing we did here. I want to get rid of the 1. All right, let's get rid of the 1 first. Okay, so we got x squared plus 3x equals 7. And now, what did we do before? We took half of this number and squared it. So that was 2 squared. That was 4. And we added that to both sides. Well, I'm going to do the same thing. Take half of 3 and square it. Well, half of 3 is 3 halves. 3 halves squared is 9/4. So that's what I'm going to add to both sides. Okay? So let's do that. So I'm going to take x squared plus 3x. I'm going to add 9/4 to the left. And I'm going to add 9/4 to the right. This is supposed to be a perfect square now. Let's see if we can see what it is. Well, you know, we kind of know how it's supposed to work out, because when we, where was the, oh, here's the formula down here. the thing that goes right here that you add when you square is exactly, 2 times that is what appeared next to the x. So 2 times that is right here. So that thing must be 3/2. So I know that my perfect square must be x plus 3/2 squared. Whatever this thing was, when you divide that by 2, that's what goes in here. And you can check it. If you square this thing out, you work it all out, you'll get this. Okay, let's simplify the right-hand side. 7 is the same as 28/4, right? So 28/4 plus 9/4 is 37/4, all right? So we know that x plus 3/2 is equal to plus or minus the square root of 37/4. And that's equal to plus or minus the square root of 37 divided by the square root of 4. But the square root of 4 is just 2. So if I subtract 3/2 from both sides, I get this. Negative 3/2 plus or minus the square root of 37 over 2. Let's try another one. Okay. Let's see what happens here. I'm going to solve this. So the first thing I'm going to do is get rid of that plus 4. Okay, because I want this to just be that piece that we were working with before. So we subtract 4 from both sides. So I just get this. Now I want to complete the square. I want to add something so that what I have is of this form, right? So that something is always going to be half of this squared. So what would that be? Well, half of 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. That's the completing the square step. So x squared plus 2x plus 1. Negative 4 plus 1 is negative 3. Okay. Now, this is supposed to be a perfect square. And we know that it always becomes x plus just half of this. So x plus 1 squared. And you can check it. If you multiply it out, you'll see you get exactly this. So now we use the square root property. So x plus 1 must equal plus or minus the square root of negative 3. And because we've talked about complex numbers, we know how to write this down, right? Plus or minus, root negative 3 is the same thing as root 3 times I. Right? When you take the square root of a negative number, it's the same thing as positive thing times I. And it's plus or minus, right? So what I'm going to do is I'm going to subtract 1 from both sides. Well, I have 3 things over here, so I subtract 1 from all of them. So x equals negative 1 plus or minus root 3 I. That's what we write our final answer as. There's 2 answers, negative 1 minus root 3i and negative 1 plus root 3i. So complex numbers can happen as well. And you will always get an answer here. If you're willing to use complex numbers, then no matter what coefficients you put here, you'll always be able to get a solution. Let's try one where we have a coefficient in front of the x squared. Here we want to solve this equation. Well, what we were doing depended on the fact that the coefficient in front of x squared was a 1. All right? If it's not a 1, then there's no guarantee that just adding half of this squared is going to work. Okay? So what we want to do is we want to turn this into a 1. We want to get the coefficient in front of x to be a 1. So what we'll do to get that to happen is we'll divide through by that coefficient. All right, so I'm going to divide both sides by 3. So the idea here is that we want the coefficient in front of x, in front of x squared, sorry, to be 1. All right, it's very important. Otherwise, the technique as I showed it to you, there's a way to do it when it's not 1, but it's more complicated. And I think it's the easiest thing to do is just make it 1. The technique that we learned requires the coefficient here to be a 1. So that's why I'm going to divide both sides by 3. So 3x squared divided by 3 is x squared. There, it's a 1. Good. 12x divided by 3 is 4x. 15 divided by 3 is 5. 0 divided by 3 is 0. There, it's a 1. Okay, so what do we do next? We add 5 to both sides. That's just to get rid of this negative 5, right? So now we just have x squared. Oh, no, it's not a 0 anymore. I added 5 to it. X squared minus 4x equals 5. Now I want to add something to both sides. Well, what is that something going to be? Well, I always take half of this number and square it. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. So we get x squared minus 4x plus 4 equals 9. This has become a perfect square. Now notice the minus sign here. That means it's going to be of the form x minus half of this squared. If that's a minus, this is a minus. So now we come up here. We use the square root property. X minus 2 must be, oh my goodness, must be equal to plus or minus the square root of 9. That means that x minus 2 is equal to plus or minus 3. Add 2 to both sides. X equals 2 plus or minus 3. Negative 1, 5.
So that was our video on completing the square. I hope you found it useful. I will see you in the next video.